DeepSeek, a new Chinese AI that just released recently that has done unimaginable damage in AI on AI related companies, especially Nvidia. Out of all of these, Nvidia being the biggest loser, its market cap, which stood at about $3.6 trillion, shrunk to 590 billion, which is a loss of 83.61%, which is a lot. Like, just take a look at these benchmarks. It's insane that DeepSeek beat all of the other AIs in maths, which is very good. So what makes this different, you might say? It's mainly these three features: reinforcement learning, chain of thought, and model distillation. So about reinforcement learning, before we learn about that, let's learn the types of learning. Unsupervised learning first. So it learns from unlabeled data, discovers hidden patterns. Key techniques include clustering, dimension reduction, and association rules. So first, an example, let's just make some white dots. Let's draw circles around them. Let's zoom out a bit, making graph lines, and then let's connect each dot to each other. So now we just did unsupervised learning. Probably if you're not one of those tech geeks out there, you probably wouldn't not have understand it if I'm not gonna explain it right now. So let's go to the animation a bit slower and I'll explain everything in detail. Okay, about unsupervised learning, learns patterns from unlabeled data, which means in unsupervised learning, the model does not have labeled data, like no predefined categories or correct answers. Instead, it analyzes the raw data and identifies patterns or structures by grouping similar data points together. So the discovers hidden structures. It's really close to learns patterns from unlabeled data, just discovers hidden structures on those data points. So mainly to do this, there's common techniques unsupervised learning models use, which is clustering. So clustering is like grouping similar data points together. For example, grouping customers based on purchasing behavior. Dimensionality reduction, it just reduces the number of features while preserving the most important information. Now association, what it does is just finds relationships or patterns between variables in like large data sets, commonly used for market-based basket analysis. Common algorithms, for example, like the a priori algorithm or the eclat algorithm. It's not about that. You can search on the internet if you want more information. Now let's continue to the example. So the white dots you see here represent data points scattered in an arbitrary two-dimensional space. Then the dots are going to be colored. What this means is that it symbolizes that the algorithm is grouping similar data points, and the yellow circles that you see right here highlight different clusters, showing that the data points within each circle belong to the same group based on some similarity. Now let's just zoom out. This is dimensionality reduction. So as I explained, it just reduces everything without getting rid of the most important information. Now then, after it finds the relationships and patterns, it connects similar data points together so that next time, based on this training, it can do the same to other unseen inputs. Now, supervised learning. Unlike unsupervised learning, we give it a labeled data set. In this approach, the model is supervised. So during that training, we give it correct input and output pairs, so that the goal is to learn a general rule that can predict outputs for new unseen inputs based on the input output pairs that the model learned from. So let me show you a brief small example. So the label data, input X and output Y. Let's make a graph. So the X-axis represents size in square feet, while being the input feature, while the Y represents price, K dollars, being the output. So we see that the model prediction, which is a yellow regression line drawn across the graph. So and the blue dots that you see on the graph represent the real data points from historical housing prices. So like this dots, like 2 square feet right here is $50K, 4 square feet $100K, and 6 square feet $200K, 8 square feet $350K. You see the pattern. Now the example of labeled data is like the blue text that you see right there. Input X size 7 square feet and output price $200K. Based on the data points, based on the given data, that we know that 2 square foot is $50,000, 8 square foot is $350,000. Now if we say to find 7 square foot, Based on the data that's given, it will be trained. After it's trained, it will give us the answer based on the input output pairs that we give it on the training session. So we see that if we wanted to find 7 square foot, it will correctly find the price, which is going to be $270,000 based on the training, because we gave it input and output pairs. Now, let's go to the reinforcement learning. So in reinforcement learning, these key features that makes it different from every single learning type. So it has an agent, it's the learner or decision maker, the environment, the world that the agent interacts with, like example a chessboard, self-driving car, basically its surroundings, and the state is the current situation or configuration of the environment. The action is a choice that agent makes to transition between states, like, and then the reward. The reward is the key point of reinforcement learning, which makes it very, very unique. It's like it's the feedback from the environment which guides the agents towards a goal. For example, if it beats me at chess, I'll give it a +1 for winning, and if it doesn't, -1 for losing. It doesn't have to be for beating me at chess. It can be specific movements that it does. And the policy is the strategy that the agent uses to select the actions. Like if in state X, do action Y. Now, what makes DeepSeek very different is that it uses the GRPO equation, or the group relative policy optimization. So it's this really long equation that I don't have the time to explain to you. So I'm just gonna put in an AI voice to just verbalize it, not explain.
The GRPO objective, denoted as capital J sub GRPO of theta, is the expectation over two things. First, the query Q sampled from the distribution P of Q, and second, the group of observations O sub I sampled from the old policy, denoted as pi of theta old, conditioned on Q. This expectation is multiplied by 1 over G, where G is the group size, and summed over all observations from I equals 1 to G. Within this summation, we take the minimum of two terms. The first term is the ratio of the current policy pi of theta for observation A sub I, given Q, divided by the old policy pi of theta old for the same, multiplied by the advantage A sub I. The second term is a clipped ratio of the current policy to the old policy for observation O sub I, given Q. This ratio is restricted to be within 1 minus epsilon and 1 plus epsilon, where epsilon is a small positive hyperparameter. From this minimum, we subtract beta, another hyperparameter, multiplied by the KL divergence between the current policy P of theta and the reference policy. P sub ref. The KL divergence, or Kullback-Leibler divergence, is defined as the ratio of the reference policy pi sub, ref for observation O sub I, given Q, to the current policy pi of theta, minus the logarithm of that ratio, -1. Finally, the advantage, A sub I, is calculated as the reward, R sub I, minus the mean of all rewards in the group, divided by the standard deviation of the group's rewards.
So when we go back to reinforcement learning, let me give you a quick example. So we see this ball, and it's in a square, so it's gonna be an action. It's gonna be moved. That's what we want the AI to do. After that, after it completes its task, it gets a reward. For example, a +1 point for it to do, for +1 point for doing that action. So what it does after that, it just goes back to the beginning and then continues learning. That's what makes DeepSeek very different from other AIs, because it's pure reinforcement learning. Okay, now we finished reinforcement learning. Now let's go to the chain of thought. So the chain of thought is like it's a problem-solving technique where like an AI model or human breaks down complex reasonings into intermediate logical steps, like showing its works instead of jumping directly to a final answer. It mimics how the humans solve problems by explicitly revealing the thought process. For example, 10 plus 10, we don't know what it is. So we just randomly put 20. Well, this is kind of wrong. I mean, it's not wrong, but there's a cases that it might be wrong. So the features of chain of thought include like step-by-step breakdown. For example, 12 plus 38. What it does is 12 it just breaks it down to simpler blocks, like 12 equals 10 plus 2, 38 equals 30 plus 8. Then what it does is 10 plus 30, which is 40, and then 2 plus 8, which is 10. So what it does is 40 plus 10, which is 50, which makes it correct. It just maps out to the other part. So, and something else is improved accuracy. So without COT, it might be wrong, but with COT, it will give us an explanation and the correct answer. Now, transparent reasoning. So what I mean by transparent reasoning is the why part. So what it does is it identifies the components, applies the rules, combines the results, and gives us the final output. Okay, it's just in a recap, better reasoning through explicit thought processes. That's chain of thought. Now let's go to the final part, which is model distillation. So what I mean by model distillation is like it's a technique where a smaller model, like a student, learns to mimic a larger or pre-trained model, which has more knowledge than the smaller one. So key features of the chain of thought is knowledge transfer, smaller model size, faster inference, and everything's performance, even being small. So for example, let's have a teacher model and a student model. So what the teacher model is just knowledge transfers to the student model, expanding the student's knowledge, even though it's smaller. Model distillation, in recap, enables efficient deployment AI models without significant loss in performance. Okay, thank you for listening. This is the end of the video. Hope you had a great time. Bye.